Can you guys hear me okay? Okay, good. All right. Looks like it also is recording from what I can tell. So in case you need to hop off, I can't guarantee that it's going to continue or that it's going to resolve before I have to log off again. So if you can listen in, that would be great. And I'm going to share screen in a smidge. I've got some board work. And so you might miss that, but what I can do is take a picture of it and then send that to you guys in an email. Okay. All right. So one of the first things I wanted to do is talk about next week's lab with everyone after I take attendance. And those of you on Zoom, can you guys see the maps? The map that's up? Okay, good. All right, let me take attendance. Kirsten? Okay. And Tyler? And Connor and Lauren? And Leslie is here, Evan. And Natalie, there you are, yeah. Olivia? Is Olivia here? There you are. And Taylor? Sasha? And Sasha, were you here last week? I can't, no? Okay, we should touch base on content before we leave today. Rebecca? Miles? Miles, did I run into your roommate? At Stewart? Yeah, we came right last week, right around the end of lab, and we went and got ice cream. Awesome. Ingrid? And Brian? Hunter? Clayton? And Francis. All right. Okay. Timothy and Jacqueline. Yes, got you guys. All right. I think that's everybody. So lots to talk about. And Leslie, if you could dim like one of the lights that makes it easier to see up here. I never know which one it is. That's perfect. Okay. So for next week, I think what we're going to do to save time is we will meet at Ruger Woods. For those of you that aren't familiar with it, I wanted to bring this and pull this up so I could show you where to go. It's right, behind the field house, and there's a couple of different spots that, you could access Ruger Woods, but we're going to meet at the yellow gate that's right near the running track. Okay, so I'll zoom in and show you where that is. So at 1 o'clock, just plan ahead, make sure you can get over there. You can drive over and park along the edge there, commute with each other if you wanted to, bike ride over, board over or whatever. But that'll be the plan. And we're going to have our forest lab, which is exciting. So in terms of where we'll go, my recommendation to all of you is, so here we are. at, right, this is where we are, yeah. So here we are at our classroom. So we're in Hudson. I would recommend to all of you to kind of bust a move over towards Ruger Street, right? And then walk Ruger Street all the way down past all the dorms, past the dining hall. And then as you get to the high school, right, this is Sibley, right? And then there's the high school that's right here. You're gonna turn just after the high school onto Adirondack Lane. And then you're gonna take that first turn that approaches this Temple Beth Israel, and that's gonna head you like zigzagged over to the field house. Okay, so the temple's right here. This used to be a parking lot that was open, but I think it's fenced in for construction material right now. But you can park anywhere like on the grassy edge right along the side here. Here's the field house. Here's the track. And there will be a gate right here, a yellow gate. And that's where I'm going to meet everybody. Okay, so at 1 o'clock, you'll want to meet right there. Yeah. And if you're confused, if you need me to send a little map, just shoot me a direct email, but that'll be the plan. No need to come here. We'll just meet you right over there. Okay. All right. The other thing is, and I'm telling you this now so that you have context for it. You can imagine this was an awkward thing to ask my, my department administrative assistant to order for me, and then for my boss to then be like, what is going on, Danielle? So it's okay to laugh. We are going to be, these are tidy whities, right? 100% cotton, no color, and they're size large. This is kind of the universal thing. So I was at a conference, the ESA conference this summer, and there were these kind of workshop sessions that offered some suggestions for some cool things to embed in labs. And what I was unaware of is that the USDA, which is a legitimate, right, organization, Department of Agriculture, right, or I'm sorry, conservation here, is doing this campaign to basically evaluate the quality of soil that farmers have on their farms, right? And so what they're trying to do is universally use one certain type of material and dig it down a little ways, 3 inches deep at your site. Don't touch it for 60 days. Remember where it was, put a little stake in the ground, right? Wait 60 days so that the microbes and the insects can do what they need to do. And then log a picture on the tracker, Undies Tracker Challenge. Go back and evaluate it. So it's supposed to completely disintegrate except for like the waistband, which boggles my mind. You know, I mean, I know that, you know, decomposition happens, and if things are wet or cold, right, decomposition rates will change. But to me, this is like an open lab. There's so many things we could do, right? We could get some that are like more polyester versus the all cotton. We can put some in warm versus dry, like north and south facing slope, the edge of the river where it might be wet versus a dry spot, different types of soil. We could even kind of sew them into like a mesh screen bag that would prevent, you know, worms and stuff from getting in. So leave some of those macro invertebrates out of the picture and compare the two. I just think it's fascinating. I think I might end up looking for some like plastic ones, you know, polyester type stuff, the blends, so that we can like pairwise put them out there and go back and see the difference. Part of the reason why, you know, we're doing this forest lab later in the semester, we're doing the worm lab, and the worms are, you know, important in relocating materials and nutrients in different depths of the soil. But also important in decomposition and nutrient recycling, which, you know, I know that Dr. Aldred does that sort of stuff for research. So I think it's a way for us to talk about decomposition, and, you know, we don't have a lab that's on it, but also you just collected a bunch of microplastics at the beach, right? And I know later in the semester when we kind of evaluate them closer, I know I'm going to talk about how big a role us doing laundry plays, right? Every time we wash anything that's partially polyester or nylon, anything synthetic, those fibers are going to end up in the waterways. And so it's kind of a way for us to speak to fast fashion, right? Anytime we buy cheap clothing, and it gets holes in it or something, it doesn't last a long time, and then we just toss it in the landfill, like what actually is going to happen, right? How long is it going to take for that to degrade? So I just thought it was kind of a cool thing we could build in, and maybe it adds a little bit of something to some of the discussions or presentations about the quality of the soil that we're going to have out in Ruger Woods where we're evaluating. So yeah, there's some cool, I think this is where you actually can go in and see across the map, maybe see if this is going to bring in. Yeah, here's the map of it. So there's all these student groups that have participated. So it legit, happened 60 days. So we will probably be a participant in this project, which I think is neat. So stay tuned. That's something to really look forward to, right? Okay. Everybody good? Next week, we're going to be meeting out at Ruger for the forest lab, where we're going to look at a wet site and a dry site. We're going to evaluate the tree communities and see if they're different. What are their characteristics? And then plant our underwear in the soil. But today we have some data analysis to do. So if everyone can hop onto I was just going to say Moodle, onto Brightspace, beloved Brightspace, and head over to the optimal foraging area. I should first ask, is everybody good with their assignment? I'm going to say maybe one or two things about the assignment due like end of day today. It's like drafting the method section, drafting the introduction section. So if you go on to the optimal foraging and you go over to the web page, it's going to pull up. Let me see if I can. I want to hide this. It has been so long since I have used, I'm trying to hide to give space here. Hide video panel. Perfect. Okay. Been a long time since I've done Zoom. All right. So if you need a refresher, I have the videos that are embedded in here. And if you keep scrolling down, this is one of the data analyses that we'll be using today, the chi-square. And we'll talk a little bit about that. But right here, see where it says raw data OFT? If everybody can click on that, it's going to go probably to your downloads folder, which you can access by, clicking on this little folder right here. You can go over to downloads and double click and open that as an Excel. Just checking there. Okay. Now make sure you hit that enable editing so that it's going to be accessible to everyone. So these are the data that you all collected last week, plus some additionals from another lab. And they're broken out by trial. So you can see these are the foragers. We've got our number of white chips, red chips, blue chips, the number of calories associated with each of those, and then some blank spots where we know we're going to have to do some analysis. Down below each trial is I should say, a chi-square table that really has just broken down the chi-square equation into steps, okay? So the key critical items that are necessary for your chi-square test, which is what this little like x squared is, right? That's chi-square. It's the sum of the observed chips minus the expected chips squared divided by the expected chips. So we'll learn how to do the expecteds together, but the observed is just how many total reds, how many total whites, how many total blues were accumulated in that trial. Okay, so that's where those come from. So basically in the Excel sheet, you'll pop in, the total whites, reds, and blues into the observed. And then for the expecteds, we'll be able to calculate that here. And so you'll notice I basically have just kind of stepped us through that whole equation, right? First, you need to figure out your expecteds, then you need to figure out your observed, then you need to subtract the two. And then in order to get that numerator, you need to square what you just subtracted, right? And then the last step is to divide it by expected again. So this right here is the chi-square equation, right? It's O minus E squared divided by E. Everything above it is just the steps broken out, right? And so our final step here is that we will sum all these little mini chi-squares for each of the colors. We'll sum them together as one, and then we'll make a decision whether or not we're going to accept the null hypothesis or reject the null hypothesis, okay? And that is based on a critical value, which again, I will talk about in a moment. So the things that are here in yellow are really important. They're going to be what helps us to make our graph, okay? And so again, just orienting you, here's the next trial, predation. Again, some calculations we've got to do. The stuff we need for our graph is in yellow. And then we have, again, an optimal foraging decision to make with our chi-square, and so on and so forth, all the way down for all our 7 trials. Good? Good for orientation? All right. Now over here on the second tab is one that breaks out predation by 1, 2, or 3 foragers. So what you'll notice is it's just a bit smaller because not everybody had 1 ball. Not everybody had 2 balls, right? So there's fewer of them. It's the same calculations, but we break it out by, I'm assuming this top one is 1 predator. I don't see that it says 1, right? I just see predation risk 2, right? This would be, oh yeah, oh, I'm sorry, totally blind, yeah. So 1 predator, and then 2 predator, and then 3 predator. To the right, you'll see a chi-square for each of them, okay? All right. Now, going back, if that's clear for everyone, going back to that main page where all of our trials are, I want to kind of just call your attention to the right-hand side. In most of the data analysis that we will do, and I'm just checking on everybody. Whoops. I don't think they're able to see that. So guys, I'm just in the middle of our Brightspace page. I clicked on the data analysis section, and I downloaded the raw data. So I'm just going to try and share screen again to this new data set. Okay. Hopefully you can see it now. So over to the right of our data, and as we mentioned, over here on the left, we've got each of our trials, blank spaces where our analysis goes. Below each is the calculation we've got to do for chi-square. But over on the right is where we're building our graph. And this is always kind of how it's going to be in my data analysis. That to the right, we have a kind of a summary table where all the important stuff goes, and a graph can be made from those. And then if you scooch over to the right here, the outcome of your chi-square, right? That sum of all the mini chi-squares is going to go right there with a decision rule whether to accept or reject the null hypothesis. Okay, so that's where all that stuff's going to go. Okay. Now there's a couple of other tabs, as I mentioned earlier, and if you read over the lab manual, there are 2 calculations that we were going to do. One was an ANOVA. And we'll do an ANOVA on the mean calories per chip and the mean calories per forager. So there's 2 different ANOVAs we're going to run as soon as we've done some of the calculations. And the data will get pasted in here, and then we can use our data analysis pack on Excel. So in order to do that, let's just do that together and make sure everybody has that ready to go for when the time comes, okay? So if you can go over to your file where it says file here in the header on Excel, click that, go down to options. Okay. And a pop-up is going to pop up here. I want you to go to add-ins on that pop-up on the left. and hit OK. What just happened? Hold on a sec. Mine like seemed to freeze for a sec. Options. Add-ins. Okay, so add-ins should then prompt like something to pop up that shows you all the add-ins that Excel has. We want to click on the analysis tool pack add-in. Okay, make that little tool pack active and then hit go. See that little go button? Okay, and now activate it, right? Let's activate that first analysis tool pack. I don't know what the VBA one is, but you can click that as well and hit OK. Everybody okay with that? So again, I went over to file, I went down to options, I checked add-ins, I clicked on the analysis tool pack, I hit go. It prompted me to check both of those tool packs and I hit OK. So now when you guys go over to the data tab on Excel, do that for me right now. Do you see on your far right-hand side, data analysis, right? When you click that, it's gonna pop up like, oh, you want to do a t-test? Oh, you want to do an ANOVA? I can help with that, right? So this should be on like all your Excels, right? You could always bring in that plugin and that'll help us to do some of the math work, okay? So hopefully that's good. Hopefully the group that's on Zoom can see that. All right. Any questions in terms of orientation, what we're going to be up to? We're going to make two graphs. The graphs, the data that are in the graphs are going to help us with an ANOVA, and then we're going to do our chi-square, and we'll be able to determine if in each of those trials we foraged randomly, like the chips were found in the landscape, or we foraged with some kind of cool strategy optimally, okay? So when I say we foraged randomly, what I mean is that we foraged according to the ratios that were in the baggie, right? 50% of them or 40 of the chips were whites. And then we had, 25% or 20 were each of the other colors. So you had a higher likelihood of picking up the white ones than you did the reds and the blues. And if we figure out that that's kind of the ratios that happened in one of your trials, then we accept the null that we foraged randomly. Like we can't reject it, right? We have to accept it. If our value in the end of that chi-square is way higher than our critical cutoff value, then we reject the null of foraging randomly in favor that we optimally foraged, okay? And so one of the things I wanted to show you all is how we calculate what our cutoff is. So the chi-square cutoff is based on a chi-square table, which is also in Moodle, like kind of near where your data set is. I'm going to pull one up here just for the people that are on Zoom and show everybody. Where did the table? There it is. Okay. So normally in science, right, we always are like, P of 0.05, right? 95% confidence type thing, right? So for us with our analysis, we're going to kind of go across to significance. 0.05 is the significance we tend to sit on, 95% confident. And we need to then also, we're going to kind of cross check where these two things meet. We're going to figure out what our degrees of freedom are. In the case of what we're doing for analysis, it's the chips, right? Red, blue, and white chips, that's 3. 3 minus 1 is how we calculate the degree of freedom. So we're looking at a degree of freedom of 2 at a P of 0.05, and where those two meet is 5.991. That's our critical cutoff, right, for the chi-square. So if we do our chi-square test, and we get a value that is below 5.991, we have to accept the null hypothesis that we foraged randomly, how it was found on the landscape. If it's greater than that, we reject it in favor of optimal foraging. You guys good with that? Yeah? Okay. Wanted you to see how that's formed. Okay. Let's get down to business, I think. So we can do this together. Like I will kind of do it up here, and anybody who is like quick on the fly can, kind of do a few of them on your own and keep going until you're all done. Our goal is at the end, everybody's going to have chi-square done. The table over here that has your chi-square and then accept or reject null will be filled in. Your graphs will be made here together, right? So let's do a few together, and then Colby and I will circulate around. I want everybody to feel comfortable with it. We'll come back together for the ANOVA part, okay? We'll talk a little bit about like the next part of the assignment. Yep.
Are we doing these on our own unique copies?
So we're all using the same data, so we're pretty much all going to have the same graphs. Yeah,
Okay.
it's just you getting the comfort level with Excel. Yep.
So on top of that, we're doing it for all the groups, then we're not doing just our group.
Yes, everybody's data combined. The larger our sample size, the stronger our confidence will be. Okay, good questions. All right, so let's put our cursor in that H2 area. And as we're doing Excel, like we've sort of tried to build, right? Early on, we just had, let's calculate means and standard deviations. These are still easy formulas that we're going to be working with today. When we do the tree analysis, we're going to build in some complexity to those formulas. And when we do demography, it'll be even, a stronger trend, right? Making it easier for you to search for things in a couple of keystrokes by using just formulas. So for total calories, right, we're going to use equals, type in equals sum, open parentheses, and then we're going to look for the calories in that row. So you're going to hit the control button and click on the calories white where the 175 is, and then click when the calories red, and then click again on the calories blue, okay? So your formula is equals sum, open parentheses, and you've clicked on the C2 cell, you've gone and clicked on the E2 cell, and you've clicked on the G2 cell. You don't even have to end your parenthesis, you can just hit enter, okay? And then you can grab, here's one of the tricks for those that are new in Excel. See this little corner, see how there's a little green box right there? Drag that corner down and stop right in the end of the white, okay? And it will calculate that formula all the way down, right? It's just updating your rows. Everybody good with that? Okay. If not, Colby's going to help circulate around. All right, so that's the total calories. The next one is the calories per chip, okay? So you'll do equals. Well, my calories are right next door, so click on your 385 and divide it, and now we need those total chips. So you're going to need in your denominator to do sum, parentheses. Now you want to click on the chips, right? So hit that control button, right? So you can grab a few things. You're going to click on the 7 for the white chips, the 1 for the red chips, and the 4 for the blue chips. Okay, and that one you can end your parentheses. So we'll look at our formula. Equals, click back on your calories, right? Divide by the sum, parenthesis, and then click, click, click on your chip counts, okay? And end your parenthesis. You guys get 32.1? Yeah, okay. Now, again, clicking back up there, you'll see your little square. You guys should be able to drag that corner down. All right. Everyone's good so far? Okay. Right. Okay, sorry, I'm just checking in on them. All right, so now we've got a kind of a blue area where we've got sums. We just need totals. So we can easily just in this one cell on that first column, type in equals sum, open parentheses, and now you want to grab the entire column above it, right? Equals sum, open parentheses, and then highlight that column of numbers above it. Don't need to even have your end parenthesis. Hit enter. Everyone hopefully gets 119. And then again, while sitting in that cell, you can grab that corner on the edge there, drag it across, stop where the blue ends. And that just summed all the way across our columns. Okay. All right, now we're getting ready to grab the data we actually need to graph, all right? So this first yellow spot right here is total calories, okay? So that means we need to find our total calories. Well, we actually just summed it up, right? It's the 99.45. So we can just do equals and click on the 99.45. And we also now need total chips. So we'll do equals. And for this one, we will actually sum. So equals sum. And now we want to click on your chips. So the first column is 1. So we'll hit control click on the 119, control click on the reds of 87, and control click on the 81 blue, right? So we're summing up the columns of chips, right? And we're going to hit enter. And you should get 287, right? So our total calories actually had its own column. Our total chips, we actually grabbed them from the blue area, right? We did an equal sum and grabbed those. Everybody good so far? Yeah, okay. All right. What we need for the graph is right over here on the right-hand side. We need the mean calories per forager, the mean calories per chip, and then the standard deviations for those. Very straightforward. Instead of doing equals sum, we're going to do equals average. So sitting in that mean calories per forager equals average, open parentheses. And this is the calories per forager. Well, we have an entire H column that's calories for each forager, right? So what we want to grab to average is that H column, okay? And hit enter to get 497. And then same deal for the mean calories per chip equals average, open parens. Now we have a calories per chip column. So we'll grab that entire column as well. Should get 35. And then if you remember back to muskrats equals STD, right? So equals STD, open parens, go back to your calories column and grab that. Don't grab the blue at the bottom, just grab the whites. That's a massive standard deviation. That must have been when Rowan was playing with you guys. And then for the standard dev calories per chip, just grab that I column. Okay, equals STD for the I column. Everyone good so far? Okay, if anyone needs help, raise your hand. No shame in raising, we'll come around and help. Okay, all right. So these values right here are what we're going to graph for our first thing. Whoops. I've got to attend to something on Zoom here. Okay. All right. Everyone is okay. Okay. So do me a favor, grab these yellows, right? And copy them. Do Control C to copy them. Okay. Scoot up to your table up here and sit right in that first cell of optimal. That was our optimal conditions, right? Bless you. We're going to right click. This is important. This is like where Excel shows the magic. Whoops. Why is it not letting me do that? Copy that. Make sure when you go there, you can right click, hit the word paste special. Okay. When you hit the word paste special, this should show up. We want to paste special values and hit transpose. Okay. So what it did was it took something that was vertical and pasted it horizontal. That's what the transpose does. Yep. I'll do it right now again. Yep. Okay. So I went down here and I copied what we knew was prized and it's yellow, right? Control C to copy it. Sit up where we want to paste it. And we're going to right click, go to paste special and hit values and transpose. And it'll paste across. You get it? No? Yeah?
Or
By any chance, can you like, maybe like, post this like before you go hard, something like that?
Oh, yeah. Why aren't you on a, yeah, you should kind of pair up with a buddy and watch on a screen. That'll be easier. But yeah, if this records fine and it, yep, I'll send it along. Yeah, but the school computer is always the way to go. Yeah, yep. Everybody else okay? Did that work, Clayton?
yeah.
Okay, all right. Okay, we'll move on. Let's skip the chi-square and let's just do more of the same for practice, okay? Scoot over. Now we're on predation, okay? So we'll go over to total calories. And we need to sum the calories, right? Equals sum, open parens. And we'll go and find the calories for this, right? So hit your control button. Click on the calories, red and white and blue. And if you can't, if like mine is kind of hiding my G column, right? So I'm going to just type it in my formula here. I'm going to just type G37. That's where my last value is. So the C37, the E37, and the G37, those are where your calories are, okay? So grab those. You should have a sum of each of those spots, okay? And hit enter. And we get a goose egg, right? Right? My formula window like blocked the cell I needed to click. If that happened to you guys too, you can always go up into your formula right here and you could type in what you needed, what cell you needed, which was G37 in this case. Okay, now that that's formula's in, you can grab that corner and drag it down. And then over here for calories per chip, that's equals, click on your calories to the left, divide by the sum of your chips. So sum parentheses, and now you want to hit the control and click on your chips, B, D, and F, right? So equals, click back on your H calories, divide by the sum of your B, D, and your F, and your parenthesis. Bless you. And you get this div 0. It doesn't like to divide anything by zeros. That's okay for now. Just drag your corner down. And you can just turn those into zeros. Once the formula has dragged down, just make these zeros. Good?
Let's see the calories slash chip again.
Yep. So for that, it's going to be equals, click on your calories to the left, H37, divide by the sum, divide by sum parentheses, and then click on the 3 spots that have your chips. So the B, the D, and the F. Okay, and you'll get that div 0, and then you drag that corner down, and then you can turn the div zeros into regular zeros. Good? Okay, everybody else okay? All right, so we'll go down to the blue area where we're going to sum everything up. So on our first blue cell, we'll do equals sum, open parens, and then we'll grab the column right above it. We'll drag that corner over. Once you see that little square, you can drag it all the way over and it'll calculate for all those other columns. And then here, we're going to sum up our total calories. Okay, so we don't need to do that because we actually have it calculated for us. It's 9610. So we can just do equals and click on your 9610. Okay, for our chips though, total chips, we do need to do that. So it's equals the sum. And we'll click on our chips column, which is our B, our D, and our F. So equals sum, open parens, click here on the B, the D, and the F. The number of chips is always lower than the number of calories. So kind of just look at your table. You can see the 3 that are lower. Those are always your number of chips, okay? So the B57, the D57, the F57 are the chips. And your parenthesis. And you've got your total chips. Everyone okay? Okay. All right, so now again, we're back over here with the mean calories per forager. That's the equals average. And we'll grab our forager, I'm sorry, our total calories column. That's across for all the foragers. The mean calories per chip will average the last column, the calories per chip column. Okay, so again, you can always look back at my formula when you go back and see equals average, open parens and grab the proper column. Now we'll just proceed with your standard deviations equals STD. And this is of the calories per forager, so the total calories column. And this one is the STD of our final column, the calories per chip. Okay, remember, don't grab the blue. Okay, only grab the whites. And hopefully you got 481 and 30, right? Okay. So when those are calculated, you're gonna highlight them and do Control-C to copy. And then you can go back over to our summary table. Now here's where you gotta be careful. Skip over the yellow areas, okay? That was one for all predators. We didn't pull any of them out by the number of balls. So you want to paste special values transpose to the all predators, which is below the yellows, okay? So you've done your Control-C to copy what you want. You're sitting right here in the all predators. Go right click, paste special, values and transpose. And there you go, right? It pasted right in, okay? All right, one thing we can do, and this kind of is satisfying, I don't know. I'm one of those weird people that likes to watch the graph grow and not just do it all at once. So let's do this. Once we're over here, let's kind of get our graph started, okay? The first graph we have to make for the homework is the trial on the x-axis and then the mean calories per forager on the y-axis. So if you guys can highlight that K and L column in our summary table, if you go and highlight that, okay, then you can go over to the insert tab, okay, and there's like a bar graph. So the insert tab up here, there's a bar graph right here. And when you click that bar graph icon, you can click the first option, the 2D column graph. Okay. So, and you can kind of scoot this out of the way. It's probably going to be in the wrong spot for, you know, blocking everything that you're doing. Okay. But what it's done is it's pretty much started us off with what we're looking to do, right? We want to have a graph, and we know there's best practices with graphs, right? We don't want to have this big title right here, right? We want our axis titles. So you can click on that mean calories per forager and you can delete it. So once it's like active, you can delete the name, mean calories per forager. And then you want to scoot over to your plus sign and check those axis titles, okay? It's going to basically create two little placeholders for your Y and your X axis. And notice, for me at least, my y-axis is like highlighted, right? And if yours is highlighted too, you can just go up into your formula window and you can type mean calories / forager, okay? And hit enter. And it's going to fill it in, right? That was the one that was active. That was my title that was active. So I could just go in that formula window up here and type it in. So now if I go down and activate my x-axis one, I could go up to my formula window and I can type in trials. Do me a favor, like triple check yourself that you don't write trails. That happens a lot. And it should start looking pretty good, right? Starting to reminisce about muskrats. Okay. So as we continue to like paste special values transpose, these graphs will build, okay? So that's graph one. And now the second graph, we'll scoot back up again, highlight your column K, hit the control button, because we're going to jump over and we're going to grab the M column. Grab your M column and your K column. Okay, holding the control button lets you grab it. And then again, go over and go over to insert that column, 2D column graph. Okay, and now you have a new one, which you can scoot right next to it if you want. And I'm actually, we're gonna do the same thing, right? We'll get rid of the header. We'll go over with our plus sign and we'll choose the axis titles. My y-axis title looks active right now, so I'll go up in my header here. Bless you.
Bless you.
In my formula, I'll type in mean calories / chip. Okay, and then I can scoot down and activate my x-axis. Again, that is also trials, not trails, and hit enter. Okay. Now, to just make it more visually appealing, if we didn't want them both to be blue, right, we could kind of click here on the bars of our new one that we just made and see the little paintbrush. You could click on your paintbrush and you can change your color. There's a style and a color option. You could change your color to like a green or something. I don't know why is it not letting me do my color change here? Like a red. That should have done all of them. Okay. Did it work for you guys, the color change? Yeah, I might have triple blinked it or something, but yeah, when you click on it, there's a little paintbrush, or if you like double click it, it's going to give you a pop-up that has like a paint bucket, and you can click on the paint bucket and choose solid fill and choose your color. So there's ways to like spruce it up if you want to change the coloring. Okay, but the key is we've got a nice labeled x-axis. If for some reason our like x-axis titles were super long, this might show up as like ... right? Because there's just not enough space. You could make your graph bigger by like, grabbing a corner and dragging it wider, right? If I make my graph smaller, see, I just scooched it down. You'll see there's the ... So now I want to kind of make it bigger. So I'll grab the corner. And now all of them are like fully exposed here, okay? But very important, it's got to be informative. It can stand alone. It's got its titles. It's everything on the axis makes sense. We're going to add error bars later, even though the error bars might be like outrageous with 107, I think we saw on one of them. So we can make a decision if we want to do that on some of these, okay? Everybody good so far?
It's Rowan's fault.
Hmm?
It's Rowan's fault.
It is Rowan's fault. It's all Rowan's fault. Okay, so let's scoot down past predation now. Let's go to winter, right? And we can, again, total calories. So that's the equal sum. Okay. And we're going to click on the calories, right? Hit the control button. Calories are the C column, the E column, and the G column. Again, my G column is hidden by my formula. So I'm going up in my formula window and I'm going to type in G72, knowing that it matches up the other ones. Okay. And I get 140. Okay, once you guys get that calculation set, you can grab your corner and drag it down. And then the calories per chip, if you remember, that was equals, click back on your calories and divide it by the sum of the chips. Sum, open parens, click on your chips. That's the B column, the D column, and the F column. So equals, click back on your calories, divide by the sum of all three of those chips. Okay, and once you got that, you can drag your corner down. Good so far? Yeah, okay. All right, so we'll go to the blue area. These are the totals, so equals sum, open parens, grab the column above. And once that cell is calculated, you can drag the corner all the way across to the blues. And then on your total cals in yellow, that's equals, remember, we've already done total cals, it's 4105 equals, just click on your 4105. But for total chips, we actually do need to sum it, equals the sum. And again, the chips are usually the smaller of the columns, right? Click on the 25, the 43, and the 42. Equals the sum of B92 and D92 and F92. Okay, now we're over to our important ones, the mean cals per forager, so equals average. And we're gonna grab our column of total calories, not the blue, just the white. And then we'll do equals average on the chip column, the last column. And then we'll do the standard deviations. All right, so once you've got those, copy them, Control C, and go up to your summary table. Put it in the harsh weather area. Right click, paste special, values, and transpose. Okay, and then bam, right, should start filling in on your graph, right? Everyone good so far? My God, the mask is like pulling my ears off of my head. It hurts. This is an act of love, I'm telling you right now. Okay. Are you all kind of comfortable with this process? Yeah. Okay. So here's one thing that I want to let you know is that we can start building. Well, actually, let me just remind everybody, you know, our predation tab that's right here, same deal, right? Once you finish all the 7 trials on our main page, you'll hop over to the predation one and do the same, right? The total cals per chip, sum it, do these, right? When you get this first yellow 4 groupings done, copy it and go back over to your trials and paste it in here. Paste special, transpose, right? Do that for the 3 that broke it out by 1, 2, or 3 balls, right? And that way we'll have a nice complete table that looks like closer at predation and how having more predators affects how you feed, okay? While you're doing that, I also want you to be aware that we can start populating our ANOVA table area, okay? And what do we populate it with? So if we're in the tab for ANOVA cals per forager, that means I'll go back to my original trials table, my first tab of trials. Do you see here? I've got my total calories per forager column. I'm going to copy that. So let's do a couple together, okay? Copy that. We're on optimal trial 1. Copy your total cals H column. Do a Control C. Go over to your cals forager ANOVA tab and right click and paste special values. Or if you guys see the little icon for the 1, 2, 3 clipboard, that's the values, and just paste it in, okay? And you can then go back to that same place and grab the calories per chips column right beside it, copy that one, and go over to the ANOVA cals per chip area under your optimal, right click and paste that one in. So these should all be like 30s and 20s on the cals per chip one, whereas the cals per forager one tends to be the higher values, okay? So again, we'll go down to, we did trial 1, we'll go down to the predation one, grab your H column, copy it, and paste special the values into the predators area. Go back to that same predators one, grab the column beside it for chips, and paste that special as a value into the predators, right? I think we did winter weather too, right? Do the same on winter. Whoops. Okay, and put that in here. And grab the one next to it. For the ANOVA, we're not breaking it out by the 3 predators. We're just gonna like look at predation all at once, okay? So are you kind of comfortable with that? I'm gonna like let everybody kind of process, get a little ways through it, and then I'll come back and we'll talk about the optimal foraging calculation, and we'll run through like an ANOVA, okay? So, Colby and I will circulate around to give you help if you need it, and just keep plugging away and building your graph, and if you need us, let us know. Yeah, because what if you have a, what if you have I don't have yeah, that way in case like by accident, you know, they put something on. Just in fact. So I've got on my phone, get some text. Yeah, yeah, organizations. I'll do the sheets and if not, figure out how to do stuff. Like not yourself. So we back to the Google Sheet. How do we do file, download app? So it's the original thing. Yeah. So when I go download that, I don't even know it. So I'll go here. And then it'll automatically go in like their Apple thing. Okay. So that I told you. Can you open Excel? Yes, I love Excel here. I love it in Excel. And I've been saved in my Excel. I can go back to the
Video file. Download.
Yeah, yeah. Well, you're following the process, right? And
It's like different things. There's always about this, I think, because it's still really different.
yeah, we always have to
Exactly.
limit us to that. But if you're following along, it makes sense. You can find both, somebody you know.
Okay,
So we're not, you're comfortable with the process.
so we're not trying to this.
No, you're gonna pull the table, the summary table and the 2 graphs.
Okay.
And that goes into the result.
Okay. You're not.
But yeah, you can let it. Oh, you need to split.
Yeah.
Yeah.
We need
Great.
No. I'm trying to go right funders and they're helping just get with their stuff. And they're like, I think I need this photo. As I'm going down, like a few spots. And they said I should take it and that is like, I could join the first, like if I do So yeah, I give it them.
Oh, gosh.
So they're not trying to say it like pending, is that.
Yeah.
But I have. Not very, it's just. Yeah, just drag on that. It's great.
Oh, yeah.
Let me just computer, one of the. Yeah.
Keep an eye on it, you know.
Keep it big for him. The truth, it's not a whole structure, it's
Yeah, okay. Well, you okay? Yeah. What is that? I know. Oh, no. Well, it looks like a bird. Well, Like, for sure, sorry.
Yeah.
So let's, these are numbers, it's like, Colby, we can stand it, give your phone. Yeah, we want to grab a picture for you and then the license. Yeah, we both and the lines. Yeah. Yeah, make sure you line them down there. Yeah. This one, I heard, yeah, something like. Oh, yeah, yeah. Okay, so yeah, on the 25. Yeah. So. Right, yeah, right there, and then it's right. And that's the other, and then you can around the one. Is that the first one that might have that? Yeah, because I just put the other. Yeah. All right, so yeah, you can put it on.
Okay.
Make sure it's set on. Definitely time after, okay? No, it's there. I don't know, stop. Well, you were doing this soon, was it recorded?
It is, so I'll send it, yeah, once it resolves, I'll send it to you guys. I think I also have some from like years back, which is the same procedure, and then you'll have the data set. Yeah, so I can send it in case you need to refer back. Yeah.
With my environmental. Actually. Yeah.
Once you guys get your first page done, all 7 of those trials, and you've like pasted it in and made the graphs, except for maybe the predation sub tab, let me know, because then we'll go and we'll do the ANOVAs together, okay? So as soon as you get there, let me know.
I don't. In the case of the wrong, it's not a fact. Oh, yeah.
Remember, you guys, if you ever get a div 0, you can delete that after you've dragged it down and convert those to zeros. Like I'm getting that here on scavenging. Your cows per chip header, right? You've got a whole section here that when you do the calculation, you'll get these div 0s. You can just, make them zeros after you've dragged it down. So the formula processes for the rest. Thank you. Colby. Yeah, fine. I'm doing these for the purpose of the Zoom that is being recorded, just as reinforcement. How's everybody doing? Okay? Yeah? Mhm.
Oh, you're good. You're the result, go ahead and first, then you paste it in. All right, yeah.
So most of you are making progress. You might be all set with your summary table except for your predation. Can I have everybody's attention at the front? If you have pasted your columns into your ANOVA, that would be what I would do now, okay? In the next minute, try and paste in those last two columns, right? And get that filled in. I'm gonna pull up my key up here in the 2 minute ANOVA together. Even if you don't have it completely finished, you can see the process and then you'll be ready to go when you are finished, okay? Sorry, okay, everybody. Okay. All right, so remember, the ANOVA tables are being filled in with your H column and your I column from each, right? Your H columns for each of your trials goes into the ANOVA CALs per forager. The I column gets pasted in the ANOVA CALs per chip, okay? So I'm gonna open up my key and run through this process with you. I'm gonna clear out my outcomes here. Yeah, you can, but we don't need, I want to show, some people are already past that, so I don't want anybody to like have to be waiting, so you can always go back to it and fill it in, but you can at least kind of run through this and see how we can do an ANOVA. Okay, all right, so everybody's ANOVAs should kind of look like this, right? Your ANOVA areas. Okay. And it looks like maybe I am short one value on this. Whoops. Okay, so because we went in at the beginning and went to file, went to options, went to the add-ins, grabbed our data analysis pack. When we are ready to do our analysis, okay, we can go to our data tab and we'll see this little data analysis little button over here on the right-hand side, okay? Now what I should say is, as you guys are building your graph and you see your graph, right? You might look at your first graph and be like, clearly there is a difference in mean calories per forager, right? Would you guys agree to that? Yeah. Okay. So in this case, across the trials, you have a prediction. I can see it in my graph. It seems pretty significant. You may be a little less certain on this graph, right? And I want to remind everybody, because we'll talk about it, this top graph in blue, mean calories per forager, that really speaks to what kind of a stress the trial was on the feeder, okay? That really gets at what competition did and all that kind of stuff. What this graph does is tell us, did we adopt a generalist or a specialist strategy, okay? And what we mean by that is mean calories per chip, right? If you have high mean calories per chip, you were really selective. You picked the like best ones, right? If you have low, you probably picked more whites, right? The ones that have the least calories over time, right? So any of the trials that had a little bit lower, and some of them are a little bit more slight of a difference, foraged more like a generalist, low calories per chip. Anybody that foraged more like a specialist in a trial had higher calories per chip, okay? And that's something that in your discussion section of your report, you'll be able to talk to. So we think that the ANOVAs should, show us some significant differences across the foragers by calories, but maybe not by chip. Maybe we'll have to see, okay? So we'll go over to our ANOVA CALs per forager. We will go and click on our data analysis button. and you can scoot it over if you want, down to the bottom or whatever, okay? And scroll up, right? We want an ANOVA, but we want a single factor ANOVA. So scroll that little kind of wheel bar up there, hit single factor and hit OK. And it's going to give us this little pop-up window, and it's going to basically say, show me your input. So if you hit that up arrow, you can highlight all your data, including your headers. Okay. Click the down arrow again, it brings you back to it. So again, hit the up arrow, highlight your data set, including your header. Click it again. And one of the things that's important, if you grabbed your header like I did, you click that button and say the label's in the first row, so it knows it's not a value. And then here where it says output range, you're going to click that button, right? And you're basically, when you click the up button, it basically says, where do you want me to plop the output? So I just like pick a open space up here, like one cell, okay? Hit that again and hit OK. And even if you don't have a complete table, you can grab like what you've got and see how it processes, okay? So it has just spit out an ANOVA. Our most important thing is down here, okay, which is the F statistic that lets me know that you did an ANOVA, the p-value, which is really, really small, right? It's to the, negative 0.19 up there, significant digits backwards, right? So you've got an F statistic, so I know it's ANOVA. If it was a t-test, it would be a t statistic. It's got a p-value, and it has a degree of freedom total of 139. So I'm going to just highlight those in a color, so you guys know that like these are the important things that I should write down or highlight like that or make them bold, because I will pull that into my results section, okay? As, the end of my figure one, I've done a sentence, I've got figure one because my eye is being drawn to the figure, and now I'll have semicolon, F equals, P equals, DF equals, right? And then Danielle knows, yes, I did a graph, and now I've done an ANOVA, and I can tell that my p-value is significant. It's different, okay? Let's do it on the other one, the cals per chip, okay? So again, go over to your data tab, go over to your data analysis button, scroll up to your single factor and hit OK. It wants to know your input range. Whoops, I'm going to cancel and just maximize here. I got to move. I'm trying to work around my Zoom window here, sorry. So we're up here on single factor. We're going to grab our input range. We're going to make sure our labels are in the first row. We're going to go to the output range and tell it where we want to plop the results. Just one cell is fine, and then hit OK. And again, what do we want? We want the stuff down here. Degree of freedom total, F statistic, p-value, a little less significant, but still there is a significant difference across the trials. And it may be that not all the trials have a huge significant difference, but maybe one of them had enough to make it significant, okay? Everybody cool with that? So those are, you need, those to know that there is actually a difference in the graph that you're seeing that's statistically meaningful. Okay, good. All right. I think most of you are done, or at least have the hang of it, so that if you were like, finishing up at the end, you're good with the graph kind of, completing. Some things that we should, because we still have to do the chi-square, some things that we can talk about. Does this make sense to you all? When you look at your foraging graph as it's being built, or if it's done already, right? Learning has high mean calories per forager. Learning has greater than the optimal. Does that make sense? That should make sense, right? When we look at predators, right? And I usually, when I'm in this big graph, I kind of just look at the predators broken out, not the summary predators, right? But having just one predator yielded more calories than having more predators. Does that make biological sense? Right? pack hunting versus a solo one. Maybe the solo one is a juvenile, like Rowan, right? And so you would be feeding differently in those respects. How about when we look at harsh weather? Harsh weather compared to your optimal, right? Think of your optimal as the control, okay? So when I like am writing my result section or writing my, discussion later, I do optimal versus the 3 predators. I do optimal versus harsh weather. I do optimal versus my 2 competitions. Optimal versus scavenging, optimal versus learning, right? So does it make sense to you guys then that exploitative competition, you ate more than contest? Where you fought, where you expended energy, right? Okay, so all those kind of make sense in terms of the stress that you felt on the landscape, right? And then if we go over to the mean cals per chip graph and we think about strategy, right? Mean cals per chip being low with 3 predators. Think about how you felt when 3 predators were after you. Were you picky? You probably just grabbed what was there, right? So that might be why you're eating more like a generalist when you have higher rates of predation, right? As you have less and less predators, you're getting pickier, right? Maybe your strategy is adjusting. With competition, interesting competition that's contest where you guys fought has a bit higher calories value. You were more of a specialist when you were fighting for it than when you were just competing regularly. Does that make sense to you guys? Right? You went and found something prized and fought for it, right? So that's kind of what you should be thinking about as you're trying to, contemplate your discussion. Okay. I wanted to just make sure we talked about that before breaking off with optimal analysis here. Okay. So if you guys can do me a favor and head back to your first tab for trials, and go to your first chi-square area, okay? All right, we'll do a couple of these together until you're feeling good about it. So remember, chi-square, as I go back and look at our lab manual, our lab webpage, right? It's the sum of the observed chips minus the expected chips squared divided by expected, okay? And we've already decided that our cutoff is going to be the value 5.991. We decided that based on the table. It had a P of 0.05. It had a 3 chips minus 1. So where 0.05 and 2 met up was 5.991. Whatever our chi-square value is, we compare to that. And if it's less than or equal to the 5.991, we have to accept the null, right? And the null was we foraged at random as the chips were on the landscape. If it's anything greater than 5.991, we reject it in favor of we adopted some kind of optimal strategy. We did something different as we fed, okay? That's what we got to keep in the back of our mind as we do this. So for the first step that I do on all of these, I say, how do I calculate my observed chips? Well, the observed chips are exactly what you've got here. 119, 87, and 81. So what I usually do, observed white equals, click on the 119. Observed red equals, click on your 87. Observed blue, remember the chips are always the lower values, is the equals the 81, okay? Those are the observed totals for your chips for that trial, all the people that were involved in that trial, okay? Now, to calculate the expected, you grab your total chips. That's the 287. That's the one we summed above. And you multiply it by the proportions that were in the bag, okay? So remember what we said earlier. We said equals the total chips times 50%, right? White had 50%, so times 0.5. Now, I want you to go back and sit your cursor on that value right there, okay? You'll look at your formula. It says B24, okay? If you put a $sign around the B on both sides and hit enter, okay? That keeps it like static. I mean, it's just gonna stay that way, okay? So if we drag across, it won't become C24 and D24. It's gonna always be B24, okay? And that's what we want to do. Yep. The like star, the asterisk. Okay, so in this is different than we've done before on any of our cells. If we want something to remain the same, we're going to put dollar signs around both sides of the letter, okay? So in your formula, put your dollar signs around the B. You got 24 that follows times 0.5 and hit enter. Now, when you drag that corner across, it's always going to refer back to my 287, okay, cell of total chips, but we need to change the percentage, right? For the blue, it's not going to be times 0.5, it's going to be times 0.25, right? Only a quarter of the bag was that color. And the same is true on our blue and reds here, right? So change your percentage from 0.5 or 50% down to 25%, right? So always referring you back to your total chips, you're just changing the ratio that was found on the bag. Everybody okay with that? Okay. So we've just taken and created in here are two really important things that we need to build out the rest of our equation. Now we need to subtract them. That's the next step we can do. So equals, click on the O, the observed, minus, click up on the expected, right? So equals, click on your value above, the 119, minus, click on the 143.5, drag your corner across. Okay, now we want to square that difference. Okay, so we can just do equals, click on the difference above, and then the caret button, the little, TP head, 2. Okay, and grab that and drag the corner across. And then our final step in chi-square is dividing it, that whole squared thing, by expected again. So equals, click on everything above, divide by the expected. Okay, what you just calculated is what I called the mini chi-square. That's the chi-square for the white. As you drag that across, it's going to do one for the red and it's going to do one for the blue. Okay, those are the mini chi-squares done for each of your chips. And the grand chi-square, the thing we compare to 5.991, is right there. So it's equals sum, and you want to sum all the mini chi-squares. So grab the corner, drag all the way across those 3. And what do we get? We are accepting the null, or are we rejecting the null? Do we accept the null that we are foraging randomly, or are we going to reject the null that we're optimally foraging?
Optimal.
Yep. Anything below 5.991, we accept the null, random foraging. Anything above, we reject in favor of optimal. Okay. So these are important for you to note, right? I can write here, reject null. It's not by much, right? Reject null, and I like to just say comma optimal foraging, okay? You guys want to grab that 8.616 value, that chi-square, and go up to your summary table over here. There's a summary table in the upper right for your chi-square. Right-click it and paste special your value of the 8.6. And you can go back and grab what your decision rule was too. And that will go in right up next to it. We'll do another one together. Okay. All right, let's go down and do predation. All right, so your observed is going to be just equals, and click on the color chip. So equals, click on your 127, equals, click on your 66, equals, click on your 94. For the expecteds, remember, this is with the dollar sign, equals, click on your total chips, and you can go up in your formula and you can put your dollar signs around the letter and your little star. And remember that the white is 50%, so that's 0.5. Okay, and now when you go and look, you're going to your total chips. It's always going to be that times 0.5, and you can grab your corner across, but you gotta remember, change your percentage from 50% to 25. And the same for your blue, 0.25. Okay. And then we'll just do our subtraction, equals, click on your observed, minus, click on your expected, drag your corner across. We're just gonna square that subtraction. Equals, click above, caret 2, drag your corner across. And then we'll divide that by expected, so equals, click on what you just did, divide by expected. Drag it across, that gives you your mini chi-squares, and you'll do your grand sum equals sum of the minis. And did you guys get 9 point something? Yeah, okay, so we'll copy that, we'll also agree to reject the null, right? You guys optimally foraged. Okay, and you'll just proceed, whoops, I pasted that in the wrong spot, I put it in one predator. You guys want to make sure you do the right thing too, drop it down to all predators, right? You've got to go and do the tab for predation in order to fill the, second, third, and fourth spot up. Okay, that should be kind of yellow, right, to remind you. Okay, so fill that in, go through, work up the optimal evaluation, whether you random or optimally forage. We'll come around and then we'll kind of convene to talk about the assignment, draft part 2. Yep. For that one, if you wanna make that I'll put them over to what's the camera, and right around the seat, both sides of the seat. After the so you can still, once you hit enter, drag the crowd, and then you change the point cloud. Okay. You get your last option.
It is.
So as reference, I have it up here in purple, right, what our null hypothesis was, and the 0.5 and the 0.25, if you ever needed to go back. It's also, I think, in the lab manual.
I know, I feel like there should be an Excel class instead of maybe the library class, or in addition to it, or in place of oral expression. I don't know. So each year, and I'm totally being honest, each year with my colleagues who went to grad school like after me, because I am more elderly than you can imagine, compared to colleagues. They have such savvy formulas that I learn a new one every year, so I count it. I think it's only been 3 years. You know, I used to highlight stuff, I used to sort things, sort them by, ascending and descending, and now I use the count this thing to find a value, to find it for you, you know. Maybe so you won't forget. So it, like in the end, like when the 3 days that you're gonna end up doing something like that, and now.
Business is like, I'm such a big one, so I'm sure the science don't play all the time.
Oh, really? There's a business science itself? Did you take it? You know any of this? Do we like it? Well,
I
nobody
think
did.
it's like all this. But you come up with this all on myself, you can just like.
Huh. Not that, yeah, I guess if you had a free electric. Right.
I think, okay.
Yeah.
It's all. After on.
No, thank you, Colby. Those are beautiful. So yeah, the higher your value of chi-square, like the more optimal you guys flourish. The strategy was really intense.
Uh-oh, you feeling okay? Yeah. So scavenging is always a weird one, because like you didn't have control of scavenging, right? So as you're sitting there thinking of how to explain that, it really has a lot to do with that other organism, not so much how you behave.
And then the labels and certain rows. And then I use a response. So you need P value, which you know if there is a difference, so it's not bad. So I might like. I don't know how it is. Nothing is related to the analysis, I'm just gonna briefly chat. Oh, you're doing a speech. An old fashioned school, but it seems like a better way to do it. So you're. I saw my desk, the one. Yeah. So why are you in the top? Yeah.
There you go.
Yeah, you can take that. Yeah.
I don't know, I would just be close that.
No round, and thought we'd get back. Lot of suckers and you know, go to Parker Mason Farm and take a left on the barn. I think it's farm. And then Parker is the end of the road for the cemetery, like it has a shed. Parker Mason is like where they used to. So go right to the end of that road. Archer, you can bear and then there's a kitchen step, or you go right into the dirt. When you go around. This is where you want to use yeah.
Wow, this is fun.
I think your oriented is not. Go up 22.
Okay.
So you're going up 22, you take a left, you start to long. And then right as you stop, are enabled dead end of the road. Everything's okay? Mr. Nova is situated, anybody needs a Nova support, call us over. If you're okay, and you just kind of needed that time to finish up, let me just talk briefly about the homework. Oh, yeah. Okay, so I'm gonna go back over here. As I mentioned, these two documents, part 1 and part 2, the rough intro methods, the results discussion abstract, more detailed content. These are really a good spot. Like I would take the content of that, paste it into a Google Doc or something, and begin kind of working your draft off of that, deleting my content as you replace it in, right? I had office hours with some students and talked about, you know,
articles, and I had put them down here at the bottom that are useful, as I mentioned, for the rough draft intro, as I open this up. Remember, we're going broad and then getting more and more specific. The final paragraph of that intro is your goal, of 1 or 2 sentences summary of method. So you did a 1 meter square plot, and then the hypothesis, right? That's right here, right? As soon as you plop that stuff in there, right, you can remove that, okay? Going back up here to your first paragraph, you're talking about optimal foraging in general. You're going to go to our page, and you're going to see the MacArthur and Pianka article referenced right there. You're going to start off by telling us what the theory is and citing them. You'll continue on in that same paragraph to talk about the 2 strategies, specialist and generalist, and how they become efficient. Remember, we talked about those 3 things. I believe I mentioned, right? Handling time. This is gonna go in garbage. Handling time. And travel time. And search time, right? So if you are a generalist, your travel time is low and your search time is low because you're getting whatever is around you, right? That makes you efficient. The trade-off is that if you run out, that if you are encountering a bunch of different random things that are around you, you might have to process them differently, and that might slow you down, right? You've got to eat them differently. So there's a trade-off. If you're a generalist, your handling time is high, but you've reduced with travel and search, okay? That's for a generalist. For a specialist, you are efficient because your handling time is low because you eat it all the time. You're really good at eating it. Your travel time might actually be high because if you deplete all the stuff at your favorite place, you might have to travel far to get to it, right? So travel, that's the trade-off, might be higher. But search time might actually be lower because you're always looking for it. You're really good at spotting it, right? So there's always going to be a trade-off in those 3 things that help in making you an efficient forager or predator, however you want to think of yourself. So when you talk about specialist and generalist, you can mention the trade-offs with those things. And that's your paragraph 1, okay? You've referenced the broad, original theorist, and then you've brought in some of these topics. Your next paragraph, though, is going to focus on the biotics, right? In terms of your trials, you had competitors, you had predators, you had scavengers. Maybe even learning, I guess, cognition, right? Being made aware through behaviors could be, put in there as well. So you need a broad, overview sentence to start it off, right? Something like, biotic factors have been known to alter how organisms forage. I know then everything else is going to be like background info, giving examples, right? So you'll go back to our page, and I'm not saying these are always what you have to use, right? But notice I've got an entire area down here that give you examples of articles you could use. Interactions between stellar jays and pine chipmunks and seeds that they're competing for. Martin and Fisher competing for, seeds in their trees. Overlap between Martin and Fisher. Red foxes and gray foxes. Turns out one eats more insects and fruits. The other one eats more rodents. Pygmy owls. That's actually, I think that one should probably scoot down. Well, that's predation. This one also predators, and then wolves probably predators. So there's some articles here, nothing on scavenging, but some articles here. If you paraphrase, find some good nuggets of like how they were efficient and how they foraged, how it changed behavior. Pull them in your own words and cite them. Again, beyond the optimal foraging article from Pianka and MacArthur, you guys could pull in these general ones that talk about optimal foraging. When you get down to the 3rd paragraph on abiotic factors, again, starting it off with a topic sentence like abiotic factors are known to alter foraging, right? And then going and grabbing some of the, nuggets from these articles, right? One that I had mentioned in class, I guess, was, you know, the Fisher and the Martin, right? With all the extra rain and it's changing the quality of the underground snow, right? It's going to negatively impact how these guys feed and survive, right? So you can pull from that. And then you end with that, you know, nicely tapered goal method hypothesis. Okay, so that's your intro. Again, I would just draw all my content into a document and begin kind of pulling it in. And then the methods, as we mentioned, the methods part, site description, memorial field, this day really hot, right? Experimental design, what was your foraging arena like? Where was your distance away for your safe zone? Subtleties of all the trials, whether it's like the time changed, but you don't have to like reiterate every single thing all the time, like that we counted both sides of the chip. You could just say that once and be done, right? Just be succinct, but enough that there's detail they could recreate it, right? The data analysis subsection should make a little more sense to you guys. Some of you have already submitted this part, right? This was due today, end of day. But for data analysis, you just say, these are the two graphs we made, right? Mean calories per forager, mean calories per chip. And we evaluated differences using an ANOVA, right? And then we did a chi-square goodness of fit test, plop in a snip of the optimal, of the equation for the chi-square. And we did that to determine if we were foraging randomly, null hypothesis, or optimally, right? Tell me what your cutoff was if you want, like you can get a little bit of detail on, you know, what you decided, how you decided the decision rule, okay? So that is the homework due at the end of day today. You guys just made beautiful graphs. And so your homework for the next time that we visit is, and again, end of day, I'm fine with it being dropped off end of day. Go back up to that same spot. Let's take a look at it. Part 2. Do not start by writing the abstract. Wait until the end, okay? Bless you. All right, that is not the one I wanted to pull. Sorry, just bear with me. Rough draft. There it is. Okay. So results. It needs 2 graphs and a chi-square summary table. Okay, so you're going to do this. In fact, you could start it right now. Okay, open a Word document. Right. Oh, we haven't added we have to add our standard deviations before we do what I just was doing. Activate, right? Go over to the plus. Go over to your error bars. This should all be good, right? Hit that right arrow. Go to the more. We want to customize it. And then we need to specify the value, right? So we'll go back over here. We're on the graph for calories per forager. We're going to grab calories per forager positive. We're going to grab the negative from the same column and hit OK. Okay. I'll do that again just to remind everybody. Okay. So you activate your graph, right? You got your plus sign. You go over to your error bars and you'll go over to the far right. You'll choose more options. You'll choose custom and specify your value. And then you're going to hit the button up to grab your standard deviation column on the forager one. You'll do the same on the negative. And then you'll hit OK. And then we'll go over to this graph. And we'll do the kind of the same deal, right? I'm going to scoot it up here. Get your plus sign. Go over to your error bars. More options. Go to custom. Specify. This time you want to grab your calories per chip. Those are crazy error bars. We'll just blame it on Rowan, right? So yeah, these are the graphs you want. So you're gonna, you know, copy these and bless you. You can paste them in. Remember, that's figure 1. So figure 1, mean calories per forager. You need your figure legend. Okay. You always need trends text above. And then the graph. And then your figure legend. And then you need trends text. And then you need the next graph. And then your figure legend. Mean cal, just the title, right? I like to say also like across trials. Okay. And then you're gonna need your table, the chi-square table. So that's table 1. Chi-square summary table. Across trials. And then you'll go over to your Excel, or you can create your own table. And paste it in. Okay. And because it's, something you're referring to, you also need a trends text for that too, right? So everywhere where I have the word trends text, you're going to write something. So I'll kind of, let's mock something up here, right? So remember I said your optimal is like your control, right? So I could say, as I look here, learning resulted in a 1.5 greater 1.5 times more calories consumed than optimal. Figure 1. Okay, that's drawn my eye. It's relative, one thing relative to another, right? You could say something like, as predation increased by 1 predator, there was a 4-fold decrease in calories consumed. Okay, something like that, right? You're always saying the differences, and you always often want to refer it back to what your control was, right? I like to start off very broadly with one statement that pulls in your ANOVA, right? There was a significant difference in mean calories per forager across trials. And you can draw my eye to the figure. And then you can do F equals, P equals, DF equals. Okay. That way you get your ANOVA info in there. You don't have to say I did an ANOVA and this is what it was, right? My eye knows that there's a trend. You've broadly spoken to there being a trend. You're telling me to look at this graph to see it. And then you're giving me a p-value to know how strong that was, right? I would do the same thing down here, right? As I start my trends text, but now it's not per forager, it's per chip, right? And it's figure 2. And you're going to change up your F and your P's and your DFs, right? To match the ANOVA for the chips. And then you'll bring in your trends text for that graph. So there's less to say on this graph, right? Everything's more dramatic on the one above. So I kind of would do something like, on average, foragers, consumed blah de blah. You've got your average, or a range from low to high. And you could speak to, in a separate sentence, the 2 that might be the lowest, so foraging like generalists, and the 2 that might be the highest, right? So there really aren't as many. And actually, I should say, you guys are in an anomalous group. Normally, they're all almost the same. Colby probably remembers that from his group. There's a couple here. Again, the Rowan effect. right? That really dropped it down to more of a generalist, than it usually is, okay? So approach it that way, right? A few sentences in the paragraph. You're not explaining why it happened. You're just stating the trend relative to optimal, right? Or relative to one another, drawing my eye to the figure. And if there was a stat that you needed to speak of, you're putting it in that first sentence, you know, those three things we needed. When you get down to your chi-square summary table, very simply, you can just say in all cases, but blank, blank, and blank, right? We foraged optimally, right? I'm just making stuff up here. And then you say table 1, right? That should be a capital. Right? So there, you know, depending on what your results are, you might end up with almost all of them, you taking a strategy and only a couple of them showing up as random. But whatever it is, let us know what they are, okay? And so I'll go back to kind of what my suggestions were, right? We need 2 graphs, we need a chi-square summary table. So we'll delete that. Graphs need figure legends and title and, you know, below them and captions above. We've done that, right? I write my trends text above and I don't explain that, you explain it in the discussion section, right? So I've given examples just like how I would start it off, right? And that you guys have already done. Yeah, and then right at the end of that sentence, you're gonna put the ANOVA stuff. You don't need to put it anywhere else. So that's it. That's what you need, right? Little blurbs of trends text referring me to the figure, your stats popped in, figure legends, table captions, and that's the results. Okay, good. All right. Now, the discussion section is going to start off, it's going to start off like specific. It's like opposite of intro, specific, and then go to broad. Okay. So start off here by mentioning what the goal of the experiment was, right? So you wanted to evaluate optimal foraging under these different conditions, biotic and abiotic, right? And then walk me through the results. So you'll say, you know, what did you find in the case of competition and predation, right? And you'll state your trend. You'll say, did it support your hypothesis, your original hypothesis? Remember you said some would be two, these would be the high, these would be the low yielding, right? Trials in terms of calories. Was that supported? Explain in your words why you think it was supported or why it was refuted. And then pull in examples from articles, right? Where competition might have reduced the foraging output, right? Tell me what they did and what they found and cite them, right? So it's basically you walked with me through your results and your graphs. Did it support your hypothesis? Build in some literature, keep walking me through it. And then at the very end, you're going to have a paragraph that has my sources of error, Rowan, the heat, right? The mowing, right? Crypsis, we lost so many chips, right? Because the colors blended in and it was like hiding in the grass and stuff, which is, you know, what could happen in real life. So lots of sources of error that you can think of, future directions, and the weather is certainly one to include, right? It was like, nobody was on their like top-notch game, right? It was boiling hot. Future directions, what would you maybe do differently? What would you tweak? Maybe you think back to scavenging, or maybe you want to add a new simulation that you think would be cool to look at. And then overall implications, a statement that's like, why was this important? I always like to think that this is important because it gives you a baseline understanding of how organisms will behave in the real world when they're under these scenarios. Then you can envision what would happen if we like had a massive like rainstorm that day, or like some kind of climate change event, or an invasive species, or more invasive predators came in, right? We can really get a baseline and then think about how behaviors might change if climate changed or invaders came in and that sort of thing. Finally, we end with your abstract. And again, this is a rough draft. I want you to give it your best shot because the more I've got, the more I can comment on, right? And the stronger your final paper will be. These are not massive points that your rough drafts are, but take it seriously, right? I want to be able to give you good feedback. This abstract is only 250 words. So you want to basically break out all your sections, starting with intro, then methods, results, and discussion. A couple 1 to 2 sentences each. Try and keep it within about 250 to 300 words. Always end with that final statement of the broader impact, right? Why it was important that we study optimal foraging. Okay, good. So draft that one up, and that'll be due end of day next week, right? If you guys need any help, reach out. I will try and have this resolve, and then I can, I have to bring it into YouTube. I forgot the process of it all. I have to bring it into YouTube so it captions, and then once I get the link, I'll send it out to you guys. Good? Okay, so do me a favor. These computers are wonky. Save what you have, finish up what you are working on, right? Attach it in an email to yourself unless you have a jump drive. And I know some of you, like, we're waiting on a buddy next door to be able to email it to you. So exchange email addresses so that they can get it to like Denali and over to Sasha and whoever else is missing it. Okay. All right. Good work today. All right.